Hello everyone, welcome to our Risk Management School. My name is Nicolai Kose and I'm a member of the Pirani team. I'm excited to be here with you today to explore the theoretical and practical aspect of the different topics that we will see. To help us delve into this session on artificial intelligence for risk management, we are happy to have with us Facundo Buffa, data scientist at Pirani. Hi Facundo, how are you?
Hi, Nicole, and hi, everyone. Thanks for being part of this webinar. How are you?
It's cool. Just excited to get started. And before we begin, I would love to invite everyone to continue learning about the world of risk management school by visiting the Pirani Academy, where you will find valuable learning materials. I will leave the link in the chat now so you can see the website. So there you are. Down. And if you have any questions during the webinar, please feel free to make them through the question and answer section. We'll be happy to answer them at the end of this webinar. Now let's begin with this exciting topic. Over to you, Facundo.
Okay, thank you again, everyone, for being part of this webinar. Today, we're going to be talking about artificial intelligence and some of its applications into risk management. The agenda is to first define this concept of artificial intelligence and understand how is it composed. And then we are going to start explaining our first application of machine learning for segmentation. And finally, we are going to be talking about natural language processing techniques and an application that we also have using ChatGPT to create a risk recommendation system. So, well, that's the agenda for today. Obviously, if you have questions, Nicole, feel free to interrupt me, and we are going to try to solve them in the moment. I'm going to try to explain like the theory first, and then we're going to go to the platform to show you all the steps. Okay, so what we can start. I think that the best way to understand this new concept of artificial intelligence is to first define both words separately. So what do we mean by intelligence? Well, that's the ability of reasoning, of solving problems, understanding complex ideas, and being able to learn quickly and learn from experience. And well, why do we say that this is artificial? Well, because we don't want to employ a human resource to develop those tasks or those problems that we can get done using a computer program or an artificial intelligence application. I mean, the idea here is that we can use the human intelligence for more complex problems and deliver like the more simpler task or to a computer program or an application that can help us. Obviously, we don't pretend that this artificial intelligence to do all the job, but well, we are going to use it as a tool to help us and maybe achieve better results or to get the task done more quickly. So, well, another thing that it's important is to understand how is it composed, this artificial intelligence, and you need to know that there are two main sub areas. These sub areas are called machine learning and deep learning. And these sub areas are responsible for developing and training the algorithms and models that we are going to use in our final artificial intelligence application. So these areas use like a huge amount of data to train the models, and this model is what we are going to use in the final application. For example, A really common nowadays application of this is ChatGPT. So we can consider ChatGPT as the final result, as the final artificial intelligence application that we use to process and generate text, also code. But we need to understand that this application was trained before using a huge amount of text data and using some deep learning techniques. So, well, this is how is it composed, this whole box. And another important thing is the other circle that you can see in the right, and it's called data science. And what's the importance of this? Well, because we need to understand that we should always need to have like a business goal, for example, a business problem that we want to solve or a business opportunity that we want to take advantage of. But that's need to be like really clear. We never need to use like machine learning or deep learning at a goal itself. These are just tools and techniques that we can use to help us achieve a business goal. In this case, for example, to solve a business problem. But that's all. So the process should ever be to first identify these business problems or opportunities and to try to fix them in a simpler way. And then if we think that the problem is really complex, well, in that case, yes, let's use machine learning, for example, but only if these techniques is going to help us to achieve a better result. So that's, I consider it really important. And well, before explaining our first application, another thing that we need to know is that in machine learning, there are two ways of training a model. These two ways are called supervised learning and unsupervised learning. Well, the supervised learning, the most important part in this technique is that we need to have like a target variable. And I will explain this with an example. So suppose that we are a bank, for example, and we have a data set with a lot of transactions from our clients. And in this data set, we have a column that identifies if this transaction is fraudulent or not fraudulent. So in that case, our target variable will be that column, the column that classifies the transactions into fraudulent and not fraudulent. So we can use this whole data set to train a machine learning model using supervised learning techniques. And we want that this model is able to predict in the future if a new transaction is fraudulent or not fraudulent. So that's the concept of target variable. Another example, let's suppose that we are a retail company. We have a data set with a lot of products, and we have a column that shows the amount of sales for each product. So in this case, our target variable, what we want to predict is that column, the amount of sales. So using this historical data, we can train a model, and this model is going to understand and be able to predict in the future the amount of sales for each product. Yes, Nicole, you have a question? No. Okay, sorry. Okay, so that's the case of supervised learning. What happened in the other case on unsupervised learning? Well, here we don't have like our target variable. What do we have here? It's like we have a data set. For example, the most common example here is an application for clustering or segmentation. So let's suppose that we have a data set with characteristics from all of our clients, and we are trying to find something, find a pattern, find some groups that have like similar characteristics, but we don't have, in this case, our target variable. That's why it's called unsupervised learning. So as I told you, the most common use is for clustering, for example, where we want to find like patterns. Another really common use case is for cybersecurity or for anomaly detection. For example, we have a data set with all of the transactions that our clients made in our bank. But we don't have the column that classifies these transactions in fraudulent or not fraudulent. So in that case, we can apply an algorithm, an unsupervised learning algorithm that identifies like uncommon transactions or weird patterns, and that can help us to finally identify maybe a fraudulent transaction. But that's the main difference between them. So, well, now that we know this, we can start with our first application. In this case, is for the section of anti-money laundering that we have in our platform. And the application is the use of machine learning techniques for segmentation of our clients. So, well, remember what I told you at the beginning. We always need to have like this business goal in mind, and that's our main goal. So, which our objective? To find groups of clients that are similar between them and different from others. So that's the main goal. And what's the purpose of doing this? Well, this will help us to understand the customers that we are dealing with. This also can be applied, for example, to suppliers or products. This will help us to discover patterns that we didn't know. Also, it's a really good first step towards transactional monitoring. And also, in some companies, it's an obligation to perform a segmentation, so we can comply with regulations. So, well, that's the goal. The objective is to identify groups of clients that are similar between them. And when I say similar, I mean that they are close to each other. Because, for example, if we plot our data set in a graph, like you can see here in the right, we can see that there are some observations that are closer to each other and are like more far away from others. So that's the way that these algorithms works. They calculate like distance between observations, and in that way they identify like patterns or groups. So we need to know that. Well, another important thing is to know like the advantages that we can obtain by applying machine learning techniques. Well, obviously, if we are working, for example, with a data set of 100 clients, what I would tell you is to, just do a manual segmentation. Because never forget, the goal is to segment our clients. So if you have a data set with 100 clients, I consider that it will be more easy to perform a manual segmentation. But obviously, if you are dealing with, for example, a huge amount of data, for example, with 2,000 clients, well, in that case, yes, you can like have more advantages by applying a machine learning technique. In that case, I consider that you can achieve a higher level of accuracy in those cases. Another advantages are, for example, automation, scalability, adaptability. For example, in our platform, you will be able to perform all the steps like really easy. For example, another case, if you experience an incrementation, for example, you go from 2,000 clients and now you have like 10,000, well, it's the same. You can apply the same algorithms and it will be good. You are not going to suffer like of time efficiency. like if you have to do it manually. Another good thing is that you can apply these algorithms to segment clients or suppliers of products. Another good thing is the personalization. For example, you can decide if you are going to use, for example, different characteristics in your segmentation. You can choose if you can consider, for example, the country of your client, or you want to consider the income of your client or not, and you can perform and apply these algorithms and compare results. And obviously, well, the time efficiency of applying these techniques, it's a lot. So these are some of the advantages. And well, now I'm going to talk about the clustering algorithm, the clustering algorithms that we have in the platform. One of them, it's called Kmeans. This algorithm tries to partition our data set into K different groups. So later we are going to talk about how to identify the optimal number of segments. I mean the K number of segments. But the idea of this algorithm is to do that, to partition our data set into K different groups. The way it performs is to first identify like different points randomly in our data set, and then it starts performing calculations to, well, identify which observations are closer to that initial point that we are going to call the cluster center or the centroid of the cluster. And this process, it's going to be repeating like 100 of times or like many times until there are no more movements, and we can just say, okay, these are the final segments. And what's good about this is that it's really simple. It's like really efficient. Also, maybe it's like kind of sensitive to initialization, and maybe it's sensitive also to outliers. But well, we're going to explain a way to remove these outliers before performing the algorithm. But well, that's the idea behind Kmeans. And the other one, it's called Birch, and this algorithm is better for more larger data sets. What this algorithm does is to first identify like observations that are like really similar to each other, and conform like a summary of the data set, a summary using like this, like aggregating like observations that are like really similar. And then using like this summary of the data set, he decides like which are going to be the final segments of our clusters. And well, this algorithm is like more robust to outliers, for example, and it's better for high dimensional data and for larger data sets. So in those cases, we should use this. But well, what I recommend is let's use both and compare results. That's really important, and decide which result is better for you and for your use case of business. Okay, well, another important step in this process is to perform a good data cleaning, because this is like the most important step in the whole process. You can use, for example, the most advanced algorithms and the most advanced machine learning techniques, but if you didn't perform a good data cleaning, you are not going to obtain a good result anyway. So, well, in the platform, you are going to see that we have like different 4 steps, and you can perform these directly in the platform. The first one is an outlier detection. And why this is important? Because, for example, we have our data set of clients. We identify that there is a client which income is like super different from the others. So this is going to generate a distortion, like in the distance between the observations. Like you can see in this graph in the right, for example, the presence of an outlier it's generating a distortion that it seems that the whole other group of observations belongs to the same cluster, but this isn't true because it's just a distortion generated by the presence of this outlier. So it's important to detect them and to remove them from the process, but never to eliminate them. We should conform a different segment of these outliers, and we should analyze them like in a separate way. Another important step is the categorical variable encoding. In this case, what we're trying to do is, for example, if we have a column that with the country of each client. So we have, for example, that one client belongs to, for example, Spain, and the other one to France. Well, but we can't measure like distance between these words. So what we are trying to do is to express this categorical variable into numerical ones. Then another step is data normalization. And why this is important? Because, for example, we have one column with the age of the client that assumes values from 20 to 80, for example. And we have another column that with the income of the client. So, well, in that case, the income, for example, can assume values from 1,000 to 5,000, for example. So it would be like really difficult for the algorithm to calculate distance between numbers like 20 and numbers like 5,000. So what we are doing is to express like all numerical data in a scale that makes them comparable between them. And finally, another important step is the principal component analysis. This is also an algorithm itself that identifies which of all the characteristics from our clients are the most important and the most relevant for the analysis. So, for example, a really simple example. Maybe we have this country column, and maybe all of our clients belongs to Spain, for example. So, well, the algorithm is going to tell us, look, all your clients are from the same country. You are not going to be able to segment clients using this variable because they are all from the same country. So you should not include this in the process. And well, in that case, we are going to exclude this column. And that would be also good for the process because we are going to reduce the dimensionality of the whole data set. So well, these are the 4 steps that we are using. Well, as I told you, another important thing is to choose the optimal number of segments. In this case, we are going to use like 2 different methods. We always try to offer like different alternatives, as we were talking about the algorithm Kmeans and Birch, to apply both of them and then compare results. Well, in this case, to choose the optimal number of segments, we are going to use 2 methods. One of them, it's called the elbow method. And this method uses a metric that it's called inertia. And this metric, it's the average of the distance from each point to its nearest center, it nearest center of the cluster. So what it's trying to do is to calculate the distance of a client to the center of the client of the cluster that this client belongs to. Well, so what happened here? That if we have, for example, 100 clients, the lowest inertia that we can achieve is if we have like 100 clusters, because each client is going to be a cluster itself. But well, we need to find like an optimal point. So the optimal point will be when the inertia it starts to slow down, and it, well, we need to choose like a number, because we need to achieve like the final goal of the segmentation, that is to segment and create like group of clients, and we can just use like 100 clusters and have like every client is separate in a different cluster. So we are going to find this optimal point. And another method that we have is the silhouette metric. This is like really common to use, and this metric use like two different parameters. One of them is called cohesion, and the other one is called separation. The cohesion parameter tries to calculate like the distance, or how how close the observations from a cluster are. So for example, in this picture, it tries to calculate the distance from all the observations from the same cluster, from the cluster that is in red color, and the separation parameter is trying to calculate the distance from the observations of the cluster red to the cluster blue. So we are trying to achieve like the optimal situation is when, for example, like this, like the picture number 1, where the observations are like really similar. The observations from one cluster are like really similar between them, and are also really far away or different from the other clusters. So well, this is the way we can like choose the optimal number. Well, now we are going to show you the platform. So I'm going to show you all these steps and how you can perform them there. Okay, this is the platform. Here you are going to find like different sections. For example, we have a section for compliance, another one for operational risk, another one for information security risk, and another one for anti-money laundering. This is what we were talking about. So here in this section, sorry, my screen just goes off. Just a minute. Okay, so here we can create and perform all the steps from the segmentation. We will be able to create a new one. I'm going to show you a segmentation I have already created, so it will be more quickly. But here is a use case for clients segmentation.
Facundo,
here,
just a reminder.
Yeah.
Sorry, I left in the link of this Pirani tool in the chat, so you can access to our software and you can do the practical exercise with Facundo. With this link, you will be able to access a 15-day free trial where you can test the 5 system that we have in Pirani. That's it.
Okay, perfect. Well, in this section, you will be able to perform like all the steps. We are going to start by choosing the variables that we want to include in our segmentation process. what is important here is to first calculate this, that is the population of the variable, and this is a metric that indicates how many not null values or not empty values we have in that variable. So, well, a recommendation is to always use like those characteristics that are over 80%, for example. If we have like this type of characteristics that are empty or are like this, like lower than 80%, well, we should like exclude them. Then the second step is to perform the data cleaning that we were talking about. Here you will be able to perform like all the 4 steps, transform like categorical data to numerical. Then we are going to detect the outliers in our data. Also, an important thing, as I told you, we are not going to remove or eliminate these outliers. We are just removing them from the segmentation process, but we are going to like store them in a different file, in a different CSV file, so you can analyze these outliers like separately and decide if it was just a mistake in the data, or maybe it's a really important client that you should analyze separately. Another important thing is the data normalization that we were talking about. And finally, the principal component analysis to identify the most important characteristics to include in our model. And then when we finish this part, we can choose like the model that we prefer. As I told you, I think that the best thing is to try 2 different segmentations, one using Kmeans and another one using the Birch algorithm, and then just analyze the results and compare them to decide which one is better for your use case. And okay, then after we choose the model, we are going to calculate like the optimal number of segments. Here, for example, I have already calculated. So using the elbow method, it is identifying that the optimal number should be 6. But obviously we should try with this method and also with the silhouette method. And then finally, when we have done all the steps, we are going to execute the segmentation. So when this process is concluded, we are going to receive like a PDF file. Here I can show you with all the important characteristics and descriptive statistics of your segments. You are going to, here you can see like the amount of data that you have, the number of segments. You can see, for example, some characteristics from your numerical variables. You are going to see, for example, characteristics from the cluster 1, from cluster 2, and it's important that you start here analyzing all the results. Try to find a business perspective on these results and try to achieve the goal that is to understand more your clients. And this is how you can perform it in the platform. Now we are going to go back to the presentation. I don't know if you have any questions, but now we can continue with the final part, that is the natural language processing techniques and the ChatGPT application. Here what it's important is to know what it means, this sub-area, that it's also a sub-area in artificial intelligence. And the main purpose of this is to combine the computer science applications with linguistics to obtain this new file that is called natural language processing. And the main objective here is not only that we are able to process text data, because before we were talking about only numerical data, but here we are trying to process like text, but not only that, also we try to that this model can understand what it means, like this text, and also will be able to generate like new human language. So that's the main goal. Some of the examples of these applications are for sentiment analysis. Most companies use like these techniques to analyze sentiment in the tweets. For example, when someone writes a tweet about their company, and we are trying to understand if the sentiment behind this tweet is like positive or negative. Also, this is really useful for comments or surveys in our company's platform to understand if we are offering a good service, and if the sentiment of these comments are like positive or negative. Another common application is to text classification. For example, an application into risk management, it would be to classify risk. We can like read all these risk that people write and classify them into different categories to understand which category is like more dangerous or is more probable that it happens, for example. And another application that is really common is to the chatbots, and this is really common to ask questions to this chatbot and receive an answer. Now in our platform we decided to apply the model ChatGPT, and it's important to understand what it means. This maybe a lot of people don't know what it means, like the letters, the G, the P, and the T. The G refers to generative, and this means that this model is able to create or generate like new data points. Remember that in this case, we are talking about text data. So this model is going to be able to generate like new paragraph or new text. Another important thing is the P, and it refers to pre-trained. This is because it was pre-trained using like a huge amount of text data available in the internet. And another thing is the T, that refers to transformers. And this is like the deep learning or neural network architecture that works from behind the model. You don't need to know this in detail, but an important thing about this is the attention mechanism that it has. And this allows the model to, for example, process like a big paragraph of text and identify in that paragraph like the keywords or the context of the whole paragraph, and to retain that information. This is like, it was like really revolutionary in that moment. There are some applications of ChatGPT into risk management. For example, one of them is what I'm going to show you in the platform, and is a recommendation of potential risk, because we identified that a lot of like new clients access to the platform, and they couldn't like identify the risk that they were suffering, or maybe they know like the risk that they were suffering, but they couldn't like write it properly in the platform. So they were like starting like calling our consultants in risk, and well, we decided to create like this system to recommend potential risk. And this system is going to be using like different key variables about the company of the client. For example, one of the key variables are the industry of the client, the process in the company, the risk system that this refers to. For example, if they are talking about compliance or operational risk or anti-money laundering risks, and of course the language of the client. And well, the process is like this picture that we have in the left. All these key variables are an input into the prompt of the ChatGPT model. And then ChatGPT used like all the information, all this text data that it was used to pre-train this model from the internet. So ChatGPT used all this information to generate a response and to make some recommendations of potential risks to the client. But also, as I told you, this is one application, but we also have like other ones. For example, risk classification. We can use like this model to classify like the risk into different categories. And another one that we are working on is to make suggestions of mitigations actions and possible causes of the risk. And so the idea is not only to recommend potential risk, but also to recommend actions to mitigate that risk and maybe possible causes. That's what we are working on. So now I'm going to show you in the platform where you can find this. Okay, so here we can go, for example, to another section. For example, we can go to the operational risk section. Okay, so here we are going to have the module of risk, where we can create like new ones. And for example, before this application, like people start like writing here risk of something, but now we are trying to offer like this suggestion risk using ChatGPT, so you can get some ideas. And here you are going to select, for example, the industry that you are working on, maybe, for example, the health industry. And you can also select the process. For example, we're going to choose this technology process. And let's just press suggest, and ChatGPT is going to start working using all the information of the internet. Well, here are the suggestions. You can read them. And well, maybe this can be helpful to identify, to use these suggestions or to identify potential risk. If you want to use one of these recommendations, you just click it. And that's all. And you can create in this way a new risk. Also, you will find like suggestions for a lot of industries, like the financial, the insurance, retail, and also a lot of process into the company, from the company. For example, marketing, commercial, customer service, and well, it's a lot that you can use. And well, that's all of this presentation. That's all what I have to show you. I don't know if there are some questions.
We have one question, Facundo. Chat tell us, ChatGPT keeps information we provide?
Well, no. In this case, we are not like giving the information that we have, for example, from our clients to ChatGPT. We are just using like these key variables, for example, the industry and the process, and that's all. We are using like the information that is from behind the model of ChatGPT to help us, but we are not giving like information to it. And well, we are doing this because we don't know like which which are the security behind this, and if data is keeping private or not. So that's what we are doing.
Great. I think we don't have any other questions. So we can do a brief summary about your presentation to our participants.
Okay. Yeah. So, well, to summary, we can say that it's important to don't lose the focus or the goal in business. We need to first understand like the business problem or the business opportunity that we want to solve, and then start thinking if we need to use machine learning or artificial intelligence for that. If the problem is like really complex, so let's do it. But if not, just keep it simple and try to always focus on solving the problem. Then another important thing is if you are performing segmentation to do like all the steps, give the importance to the data cleaning part, because that's the most important part. As I told you, you can use like all the algorithms that you want, but if you didn't perform a good data cleaning, you are not going to get a good result. And then obviously always compare results, like using both different methodologies, but at the end you need to compare and try to choose which one is better for your company. And well, that's it. And if you need some recommendations of risk, just use our section of ChatGPT to get them.
Thank you so much, Facundo, for your valuable participation in this webinar. Finally, I would love to invite everyone to participate in the short survey that will appear when this meeting ends. That will help us a lot to continue improving our webinars. Thank you so much for your participation, and see you soon.
Thank you. Bye-bye.